So welcome back to Option Online Classes. Myself Johnson. Today your chemistry teacher. Today we will discuss about that 6th class chemistry, materials and things. Already previous class we will discuss about solid characteristic feature. Shall we go to that brief? Okay. So all the materials around us made up of matter only. Okay. So definition of the matter. Matter may be defined as anything that has the mass and occupies some spaces and can be perceived by one or more of our senses. Okay, examples of the definition of the examples of the matter. Okay, water, milk, salt, chair, cloths, etc. Okay, heat, light, sound, electromagnetic radiation, these are not a matter, these are the various types of the forms of the energy. And physical classification of the matter. So matter can be classified into the three categories according to the physical state. These are the three types of that categories are present. One is the solid, second one is the liquid, third one is the gases. Okay, solid. What is the meaning of the solid? Solid means an object is said to be solid if it has a definite shape and a definite volume is present. Definite shape and definite volume that cannot be changed easily, that are called solid. Examples of the solid: chair, table, iron, sand, wood, pencil. So liquids. So liquids means an object is said to be liquid if it has a definite value but changes its shape quite easily, that are called liquids. Examples of the liquid: water, milk, kerosene, mercury. Next, last, gases. An object is said to be gaseous if it has neither definite value nor definite shape. Examples of the gases: air, steam, methane, hydrogen, oxygen, carbon dioxide. Now, general properties of the solid, already last class once we have studied, once in that brief. The intermolecular force is very strong in the solid, so the molecules are very closely packed. They cannot move away from one another and can only vibrate about the fixed position. These facts explain the general properties of the solid. Generally examples: pliers, helicopters, false teeth, bulldozer and jackhammer, submarine, forklift, clock, hammer. These are all the examples of the solid. And characteristic features of that solids have the following general properties. Okay, a solid has a fixed shape and fixed value. Solid has a fixed shape and fixed volume is present. So this is because of the molecules cannot move closer to or away from each other. You can see that these are arranged very closely packed. And solids are generally cannot be compressed. If that compressed also, they cannot change the shape. So that means this is because of their volume cannot be reduced by applying pressure on the solid. Intermolecular space in the solid is very negligible. So that means here it is very closely arranged pack. Okay, there is no gap. Like so these are the arranged in that very closely. And the intermolecular space in the solid is negligible, so the molecules cannot be pushed to the closer. However, the porous solid like that bread has the air space which makes easily compressible. Okay. Next, a solid does not flow. This is because of the molecules are tightly held in their position. They cannot slip over they cannot move to that one place to the another place. These are the tightly packed. A solid expand or contracts very little bit. For example, if you know iron, if you are applied to the heat, that expand very little bit. It is very negligible. That is the characteristic features of the solid. A solid expand or contracts very little on being heated or cooled. And the being heated, the molecules become more energetic and vibrate to a greater extent. However, they do not leave their position entirely, and so the expansion is very small. When you are heating a pan or nail, it expands so little that you do not notice it. But when the liquids such as the mercury, if you are applied to the thermometer heat, it is expand quite a bit long. So that is the difference between the solids and liquid. So on being cooled, the molecules of the solid became less energetic and vibrate less about their position than usual. So the solid contracts. However, since the molecules cannot entirely leave their position to come even closer together, and contraction is little. So these are the characteristic features of that solids. Already previous class we have discussed. Today we can discuss about that. Okay, characteristic features of the general properties of that liquids. Okay, now you can see that first of all examples of the liquids. Examples of the liquids. Fresh water is the example of the liquid, and melted snow is the example of that liquid. River water is the example of the liquid. Beach water is the example of the liquid. Milk, okay, coca, bath water, sink water, soup, juices, everyday oil, kerosene, okay. So day-to-day life juices, these are all the liquid form. Kerosene, these are all the liquid form. So here the intermolecular force in that liquids is the intermolecular space gap is more. Okay, so that means the intermolecular force is the weaker than the solid. Solids you can see very tightly packed, but so the molecules are the farther apart and are not tightly held in their position. Gap is there. Okay, therefore they can slip over another. They can move to this and this. They can move to this. Okay, so in other words, liquid can flow. Liquid can flow. Now you can see that characteristic features of that liquid. Okay, so what are the characteristic features? Now coming to the point, liquids have the following general properties. Liquid have the fixed volume is present. This is an important point. Liquid have the fixed value but no fixed shape. What are the container we are using, that shape we are getting to the liquids. Okay, this is a very important point. Liquid have the fixed value, but solids already fixed value is present, fixed shape is present. But liquids have the fixed value, but no fixed shape. Which of the container we are using, that shape only they are getting. So that is the characteristic features of the liquid. That is the characteristic features of the liquid. Next, liquid takes the shape of the container it is in. Okay, if you are which container you are using, that shape you are getting in the liquid. That is the characteristic features of the liquid. Pour equal quantities of the 300 meters of the water into the containers of the different shape. In each case, the water will take the shape of the container. In every case, the volume of the water will remain the same. But if you are what are the container you are using, that shape of the container we can see. That is the characteristic features of the liquid. Next one is the shape of the liquid change as the molecules can slip over one another and settle down, assume the shapes of the container into which it is poured. However, the volume does not changes. The molecules cannot come closer to or move away from each other. So here total point, what is the first point? Liquids have the fixed volume is present. Liquids do not have the fixed shape. That is, what is the container you are using, that shape of that container that liquids are occupied. That is the foremost important point about the liquid. Next, second point. Second point, a liquid can be compressed only small extent. The intermolecular space in the liquid is not very large. Okay, so the molecules can be pushed closer to a limited extent. So that means here you can see the distance. You can see the distance that they can move this side and that side. So that means liquids can compress to only small extent. Next, a liquids can flow, the intermolecular force being very weak. Here, what is the force is present? A very weak. So that's why the molecules can slip over another. So that means this come to this and this also come to this way. Okay. So liquids expand or contracts more than the solid. So why? Because solids have the fixed shape and fixed value is present. But these are the not fixed shape. Okay. So that's why intermolecular force is very weak. So that's why liquids are expand or contract more than the solid. When a liquid is heated, the molecules move more vigorously and go further from each other and the liquid expand. So based on that, thermometer is principle of that liquids are when you are applied to the heat that they can expand. They are prepared, thermometer is prepared. So in this theory only. Next, okay, a liquid expand or contract more than the solid over. Okay, so when a liquid is heated, the molecules move more vigorously and go further from each other and the liquid expand. The expansion in a liquid is greater than the solids. That is another important point. The expansion of the liquid is greater than the solid because if you remember, the molecules of the solid cannot leave their fixed position. Okay, but they can move. When a liquid is cooled, the molecules become less energetic and move less vigorously. They come closer. Also, the intermolecular force attraction bring them become closer still. In other words, that the liquids are contract very fastly when you are compared to the solid. Next, last point, all liquids do not mix with each other. For example, water mixes with the milk, honey, alcohol. Okay, all the liquid do not mix with each other. Water mixes with the milk, honey, alcohol, but not in the oil. Okay, liquids which mix with each other are called miscible liquids. Okay, liquids which mix with each other are called miscible liquid, and those which do not are called immiscible liquid. That is the new point. Okay, immiscible liquids means what? Which do not not mixed with the water. That is called immiscible liquids. Okay, liquids with mix with each other are called miscible liquids. That is the 2 point. Liquids have the fixed value but no fixed shape. Liquids can be compressed only to small extent. Liquids they can flow, and liquids expand and contract more than the solid, and all the liquids do not mix with each other, and liquids which mix with each other are called miscible. Liquids those which do not mix each other, that is called immiscible liquids. Next, next point, next, general properties of the gases. General properties of the gases. So you know very well Examples of the gases: fire, steam from cocoa, dragon's flame, and candle; lava, steam from soup; clouds, evaporation, steam from grills; gas smell, so oxygen gas, carbon dioxide gas, and nitrogen gas. So all the gases is there, they are state in the gases form, because you know very well that intermolecular space is much larger. For example, here one of that molecule, here one of the molecule, here one of the molecule, here one of the molecule. So that means like, okay, so distance is more, okay, weaker in the gases than the solids. When you are compared to that solids and the gases, that intermolecular force is very weak, okay. And next, because they are very weak intermolecular force, gas molecules can move about much more freely than the solids and liquids, okay. And next, in fact, they can move about all the direction. Gases also they can flow. So liquids and gases are called fluids because of their ability to flow. That's why they are called fluids. They are called fluids. Now we can discuss about the characteristic features of that gases. Okay, shall we go? Yes. Next, a gas has neither fixed value nor fixed shape. Already we can discuss about that. Okay, if you see the solids, they have the fixed shape and fixed value. If you see that liquids, okay, fixed value means there is no fixed shape. In these gases, that is the characteristic features of the gases, neither a fixed value nor a fixed shape. Okay, so that means the volume and shape of the container that is getting. Okay, so it assumes the volumes and shape of the container. That means, remember that unlike liquids occupying the entire volume of the container, this is because of the molecules are very free to move in all the directions. So that's why neither the fixed value nor the fixed shape. Okay, so that is the first point of that gases. Second point, gases can be compressed to much larger extent than the solids and liquid. This is a very important. Gases, they can compress to much larger extent than the solids and liquid. This is because of the molecules are very apart from the gases. And come much closer when their pressure is applied. So that's why you can push in a lot of air into the small volume of your cycle tube, because air is very compressible. For example, you can see that applied to that perfume, they can move very fastly. Why? Because the intermolecular force very little bit and they can molecules very distance present. So that's why. Next point, okay, so you can see that a gases expand or contracts to a great extent on the being heated or cooled. Okay, third point is a gas expand or contract to a great extent on the being heated or cooled. So that means on being heated, that gas molecules become more energetic and move even further apart. In other words, they can expand very fastly when you are compared to that, especially for the solids and liquids. So that means because of the intermolecular force is very small, the expansion is the great. So that's why they can move very fastly. And the being cooled, that gas molecules become less energetic and move less vigorously. This brings them close enough to intermolecular attraction to come into play. So this brings the molecules closer still. The intermolecular space is considerably reduced. In other words, the contraction is the great. Gases freely mix with one another because the molecules of the gases can easily occupy large intermolecular space of another gas. This property is known as the diffusion. Diffusion means movement of the molecule, they can move to that higher concentration level to the lower concentration. Both the concentration is the equal. So generally if you are applied to that perfume, that is the example of the diffusion. If you are applied to that blue, added to that white glass, that is also applied to that diffusion mechanism. Okay, so that means movement of the molecule, they can diffusion very fastly we can see in that gases. Okay, but we cannot see in that diffusion mechanism in the solids and liquids. Solids and liquids. Okay, so that means what is the main important points of that gases? Gases, a gas has neither fixed volume nor fixed shape. Gases can be compressed to much larger extent than the solids and liquids. A gases expand or contract to a great extent on being heated or cooled. Okay, gases freely mix with one another because the molecules of the gases can easily occupy in the large intermolecular space of another gas. This is the property is known as the diffusion. Now coming to the point. Now coming to the point, a comparison of the properties of that matter in that three states. So properties, serial number 1, 2, 3, 4, 5, 6, 7, 8. Okay, property, intermolecular force. So in that solid, it is very strong. It is very strong when you are compared to the liquids, weaker than the solids. So in that gases you can see the intermolecular force is the very weak. So that means this is the very strong, this is the weaker than the solid, this is the very weak. Intermolecular force, intermolecular space. So intermolecular space is the very small, and so this is the larger than the solids, and this is a very large. You can keep in your mind. Okay, intermolecular space is the very small in the solid liquids. So intermolecular space is the larger than the solid. In that gases it is a very large. Okay, shape, property of the shape. If you see the solids have the definite shape is present. Definite shapes are present, but liquids, if you see the liquid take the shape of the container but do not necessarily occupy all the volume. What is the container we are using, that shape liquids are occupied. Third, in that gases takes the shape of the container by occupying whole of the space available to them. So that's why gases take the volume of the container. So they have the definite shape. These are the liquids, and gases do not have the definite shape. Next one is the value. Next one is what? Value. So if you are see that value, solids have the definite volume is present. Definite volume is present. If you are see the liquids also definite volume. Okay, but if you are see the gases, takes the volume of the container. Okay, why? Because intermolecular force, intermolecular space very large between them, so that's why they do not have that fixed volume or definite volume. So only solids and liquids have the definite volume. And the next one is the property, rigidity or flexibility. Rigidity and flexibility. Okay, so rigidity, flexibility, in that solid there is no rigidity, there is no flexibility. But if you are see the liquids, if it is flexible. Okay, so in that gases also we can see the flexible. And compressibility. If you are press it, there is no change. In the solids almost nil. So that means there is no compressibility. Compressibility is a nil in the solid, and liquids almost nil in the liquid, and gases compressibility is a very large. We can see in that gases. Okay, next one is the density. If you see the density, solids have the large density. And liquids also have the large density, and gases have very small density. Diffusion, solids do not diffusion. Liquid diffuse slowly, gases diffuse rapidly. So these are the characteristic features of the properties of the solids. Okay, intermolecular force, intermolecular space, shape, volume, rigidity or flexibility, compressibility, density, diffusion. These are the character. What are the characteristic features of the solid? What are the characteristic features of the liquid? What are the characteristic features of the gases? So these are that. Total, if you are studying this box, all the characters study at a time very easily. Next you can see, if you are applied to the solid, actually matter is three states are present. One is the solid, liquid, gases. Okay, so solids, if you are applied to the heat, if you are applied to that heat, that is changed into the liquids. Okay, if you are applied to the liquid, okay, applied to the heat in that, applied to that, okay, so then that liquid changes to the gases. Okay, gases. Okay, so that means if the gases weaken condensation, that is changed into the liquid. That liquid, if you are freezing again, that changed into that solid. If that, next this gases also sometime changed into the solid state. Next, recombination means that gases changed into the plasma, that is the fourth state of the matter. Okay, actually we discussed in the three state: solid, liquid, gases and plasma. Solids, if you are applied to the heat, changed into that. Example, you know very well, ice. If you are applied to the ice, changed into the water. If you are applied to that water heat, that changed into the water vapor. Okay, so that means that gas also converted into that liquid form, liquid also converted into the solid form. So that means next point is soluble substances, insoluble substances. Which of the things are dissolved in the water, that is called soluble substances. Do you know very well? Salt, soluble substances. Sugar, soluble substances. If you are taking the stones, insoluble substances. Okay, so that means water can dissolve in it all kinds of the solids, liquids and gases. However, certain substances dissolve rapidly, whereas certain substances very slowly. So the substances which dissolve rapidly in the water are called soluble substances. Soluble substances. Examples of the soluble substances is, okay, common salt, sugar. Common salt and sugar is the examples of the soluble substances. Next, the substances which dissolve very little or do not seem to the dissolve are called insoluble substances. For example, glass, metal, stones, these are the examples of the insoluble substances. So that means it must be remembered that all the substances dissolve in the water over a period of time, which may be a few minutes or few centuries. It because of this property that water is called universal solvent. Water is a very important thing. Okay, water also known as the universal solvent. What is the boiling point of the water? 100 degrees centigrade. What is the melting point of the temperature? 0 degrees centigrade. That water changed into that. Okay, so in the form of ice. So that melting point is the 0 degrees centigrade, and boiling point, water changed into the water vapor, is known as the boiling point. Boiling point is the 100 degrees centigrade. So water is the water also known as the universal solvent, because all the things are dissolved in the water. So that's why. So in our body also 75% of that our body is occupied water. So water is a very important. So digestion purpose, so many purpose. Okay, distributed to the different parts of the body, and oxygen distributing, and carbon dioxide distributing, and what we are breathing, that oxygen. Okay, what is the waste material they can send to that excretory part near that. So that's why there is no water, there is no life. So in that entire life, water also very important natural resources. We can conserve the water, save the life. Okay. So water also known as the universal solvent. Water also known as the universal solvent. Now, main important points. Any material which has mass and occupies space is called matter. Okay. Any material. So, matter means any material which has mass and occupies space is called matter. Matter exists in the three states. Matter exists in the three states. That is solids, liquids, gases. Solid, liquids and gases. If you are see the solids have the definite shape and definite volume because the intermolecular spaces are very small and the intermolecular force is very strong. Because so that's why solids have that definite shape, definite volume is present. Liquids, if you see the liquids have the definite volume but do not have the definite shape because the intermolecular spaces are more than the solid and intermolecular force is the less than the solid. So that's why those molecules can interchange their places. So that's why liquids have the definite volume but do not have the definite shape. Third one, gases. If you see the gases have neither definite shape nor the definite value because the intermolecular space are very large and intermolecular force also very negligible. Okay, so these are the characteristic features. So everything is occupies space and volume, mass and volume is called matter. Matter is exists in the three states, solids and liquid. Solids have the definite shape and definite volume. Liquids have the definite volume but do not definite shape. Gases have neither definite shape and nor definite volume. And when two solids are kept in that contact with one another, they do not mix with each other. That is, they do not have the diffuse. The particles of the two different liquids can diffuse into one another depending upon the nature of the molecule liquid. For example, milk and water particles diffuse into another. So, but the particles of the oil and water do not. So, the gases diffuse into one another rapidly from the homogeneous mixture. So, this is about the materials and things. Okay, so this is about the lesson about the materials and things. Okay, so total we can today discuss the introduction of the definition of the matter, physical classification of the matter, general properties of the solid and general properties of the liquid, general properties of the gases. Okay, a comparison of the properties of the matter in the three states and what is the soluble substances, what is the insoluble substances. These are the definitions. Okay, solid, liquid, gases and example, and this is the general properties of the solid and this is the general properties of the liquid, this is the general properties of the liquid, this is the general properties of the gases, this is the total comparison of the three properties of that solids and liquids. Okay, soluble substances, insoluble substances. This is about the total lesson about the materials and things. Materials and things. Okay, thank you, have a great day.